Hi, everyone. This is Ron Vadum from Atlanta Functional Programming. Welcome to another Common Lisp study group. Today, we'll be discussing Chapter 15, which is really a case study of and almost a completion of the discussion that we had on the Pathname library. Path names and file I/O inside Common Lisp. I thought we'd just get started here. I apologize for running a little late here, but we waited a few minutes and there were some technical issues I needed to resolve before we got started here. Just a couple of announcements. The next couple of weeks, we will be discussing object orientation, which is coming up, the next two chapters, but it's going to be a bit of an involved things because there are several deep topics in there. So don't rush reading through the OO stuff in when you get started on it, because some of those concepts are a bit. Well, when I went through it the first time, I still had to kind of periodically go through to really understand Common Lisp's way of doing OO versus using a language, say like C++ and Python. But I'm giving you a heads up now because some of those concepts will take a little bit of time to really understand as we go through it in the next couple of weeks. Hopefully we could get someone like, we have someone here locally that really understands like the Smalltalk school, and the Common Lisp object system is very much similar. I mean, there are some new innovations on top of that, but the basis of it is based on message passing in the Smalltalk school of object orientation. So we're hoping to get him on board. Other things, again, I'll mention towards the end of the program as a reminder. Before we get started on the case study, actually, this is some new stuff that is probably the first time you've seen it inside the book when you guys started reading Practical Common Lisp. And sure, I forgot that this is where it actually mentions this, is the notion of read-time conditionalization and bringing in implementation specific like APIs and stuff around when you're creating portable Common Lisp libraries, especially. As we mentioned last week, with regards to path names in particular and file I/O, different Lisps sort of work very much differently because the standard didn't really specify certain aspects when dealing with file I/O. And this is just one of many features that the standard itself never really specified. So because of that, a lot of, I would say, fragmentation or innovation, depending upon how you look at it, were done within different Lisp implementations. So depending upon which Lisp you have available, you have more features or less features, depending upon how you look at it. So to deal with this so that you can actually write portable Common Lisp libraries, the Common Lisp hyperspec and most Common Lisp implementation bring these two reader macros in, hash plus and hash minus, as you can see here. These reader macros, when it reads in the actual code and compiles it, checks to see what implementation that you're on. And if you use hash plus, what that means is it looks at the implementation or looks at the next expression, really. And if the expression returns true, it'll go ahead and then execute the function after the expression. So in this example with foo, if we say that we are running, say, SBCL, when we load this into the REPL and into Lisp, what ends up happening is this will be read in like do another thing in SBCL. In Allegro, it would be read in as do one thing. And everything else, at least this is what the spec says, and this is what it was mentioned actually in Practical Common Lisp. Everything that is inside here that is not evaluated to true is actually ignored by the reader. Now, I'm not entirely sure whether or not this is absolutely true, but I'm taking it at face value. Michael, do you have anything to add regarding read time conditionalization that I might be missing?
Nope. This happens at read time, before the compiler even sees it. So as you can see, his implementation has the feature SBCL, and that's why it's highlighted, and everything else it's grayed out.
Yeah, in Emacs, it'll take some getting used to, but red means grayed out. It's being ignored.
Yeah, that's his thing. Yeah. But yeah, this happens before the compiler even sees the code. It's reading it as just do another thing inside the function body.
And so when it gets compiled, this will actually allow you to, in one place, have all the code to write a portable library. Of course, I tend to take the approach of creating small additional libraries that are specific to an implementation, and then execute the proper function based on which implementation is available. But you may certainly write your code this way as well. I don't know, it depends on the style guidelines that one adopts has to pick one versus the other. One has better modularization and better readability, in my opinion, versus others. But it is important to note that these are available for you, and the reader knows what to do when it sees those particular expressions. One thing to note is right here, it will allow you to do complex expressions, primarily ors and ands, so that you can even further tweak your library based on specific subsets of implementations, especially if they share a common set of APIs that you want to leverage to really make your Lisp library really highly performant or even more reliable. But of course, when it comes to read time conditionalization, this is specifically for the standpoint of portability, and it's heavily used in this case study, primarily because, again, as we will see shortly, some of the functions that are even specified in hyperspec, depending upon the implementation, has certain features added and certain features removed based on which common Lisp implementation you are dealing with.
Just one clarification.
Mm-hmm.
The hash plus does not work with arbitrary expressions. It only works with feature expressions. So
features
it has to
like
be,
star features, right?
Yes, it has to be a keyword or a symbol in features, which is a list you can inspect just by typing star feature star.
Right. So if we want to see an example of this,
should come back here and wave
for
at them.
example,
Stand behind me and wave at them.
Right. Only those are allowed in the hash plus or hash minus feature check.
So, and we'll shortly start, looking more into this. When you start really doing some more programming, you want to look at whether or not a particular feature exists. You really want to leverage this.
You can, at read time, push features into that list, like your own, if you were
if you were designing.
Yeah.
Right. That makes sense. So you can extend. This is how you would extend then your Lisp system as you were to create some more advanced functionality. So if you see here, for example, with SBCL, which I thought was pretty cool. All right.
As a matter of fact, if you look in there close, you might be able to find QuickLisp and Slime.
I do see Swank.
Yeah, Swank and the first two right there. Yep.
Yeah, Swank and QuickLisp.
They modified the list for you.
Yeah, so that's pretty cool. And and this actually brings up something else about your Lisp implementations. If you want to know if a particular feature exists or not, this is the best way to really know what is available in your Lisp implementation. Like I was showing earlier, there are some high performance features inside SBCL, and they're listed here actually, like memory barrier operations, atomic operations. Like if you wanted to do things with like high performance computing, they actually have some of these features mentioned in this list. And of course, your user manual in your Lisp implementation will also specify more. But in case of this case study, it's particularly useful for when we were talking about writing. We're going to be using readtime conditionalization, at least, to deal with specific implementations, specifically their implementation of the directory and probe file functions. So if you guys read the case study, I don't have to mention that the two specific things that the case study talks about, and then it also in that chapter talks about how to walk a directory too as well, which we'll get to later, is listing files in a directory and searching if a file exists. Now this happens so often. I mean, this is probably a base thing that you would probably expect any Lisp implementation to have, or any programming language to have. And surely enough, it is there. But depending upon which Lisp you use, you might the interpretation of some parts of the spec are somewhat different. Like for example, if you look at the directory function itself, directory takes in if you're especially trying to list a special kind of name called wild, a special kind of path name called wild, that you need to add to different components of the make path name object. And what happens is the directory function will detect that this symbol exists in those components, and then it will go ahead and use that as a wildcard to actually go through and list directories based on that pattern matching algorithm that's built into the Lisp implementation. Now, I'm going to say up front that the pattern matching algorithm, and this was mentioned inside the book, is not defined by the language standard. So it might be doing regular expressions, it might be doing something else, it might be depending on the host operating system's ability to do pattern matching on looking for files inside the file system. It is implementation specific, but you don't really need to know how it works. You can look at, but if you want to know, it's not in the standard. You have to go and look at your specific Lisp implementation to see how it's handling those kinds of things. To show you an example of this use is we can simply do a wildcard here on listing the directory of user Vadim. But wait a second, it only showed the list of users. Well, this shows one thing, which I mentioned later on, is a problem. Since this string, this name string, is in file form, not directory form, what make path name did is, because I said it's a wild, it actually treats this as the equivalent of doing directory on users star, and it actually lists everything inside the users directory, not in user Vadim. So you need to actually specify the trailing slash before in order for you to actually have it recognize it has a directory and list the things in the directory accordingly. Obviously, that would probably piss people off. This is something that will be very frustrating for users when you're going through it, and we want to be able to generalize it so that we can detect whether or not that slash is there, whether or not the path name is there. So the chapter goes on to talk about a couple of helper functions that one can write, certainly. One of which I wanted to actually discuss in terms of logical operations. As you can see here, this is building a function on checking specific components inside of a path name object. Now, one thing to note is this unspecific, if you haven't seen it in the footnotes, the standard actually says that Lisp implementations can return this value for different path name components. Now, I've never actually seen this used through my usage, but I'm sure others may have. So this is the best way to ensure that you're writing writing a predicate that will handle all cases. You're checking to see that it's either available or that it's nil or it's unspecific. The second thing is obviously directory path name. You're checking to see if it's a path name or not. Now, originally, if you look in the book, this is why I was bringing up logical operations. This is what was written in the book. It's written like this. And, you know, I was looking at this when I was reviewing it, and I was surprised that he actually put P at the end. Because if P is nil, right, you'd want it to shortcut the rest of the actual operations and then, you know, just return nil. But I was surprised that Peter didn't write it that way. I switched this actually to have P as the first thing to check to see if it actually is a nil object or not. I don't know if it's going to change the code execution, but it will at the very least result in fewer function calls because you're not actually calling path name on P because P doesn't exist. So I'm wondering, at least to the experienced Lispers that are on the channel, is that notion correct? Like, should we reorder the
actually, there is a particularly good reason why it was ordered the other way. I'm pretty sure. For one thing, in general, most predicates don't return nil because you passed them nil. They type error. If without the P at the beginning there, the moment you pass, you know, nil to path name, it'll type error. So, you know, at least there's that. And having the P at the end, only reason I can think of for doing that would be if they want, if, you know, you want the true value to be the path itself. Given we have generalized Booleans. Anything that isn't nil is true. That's the only reason I can think of for having P in there at all, to be honest. Okay. Would be because you want the true value to be the path itself. Although, to be honest, I tend to, you know, not use that too often because it tends to make code that just looks strange when you rely on odd return values from predicates. So I probably would have, I probably would just not include P at all in there.
So you're just saying
personally,
clean it up completely and just do this.
Yeah, because there's no point putting it at the beginning because you don't actually want it to return nil because it was past nil. You want it to throw an error. If, you know, you're passing nil to directory path name P, something has gone wrong.
Right. Absolutely.
And you probably don't want to have P at the end because the only reason you do that is because it changes the truth value that the predicate returns to be the path name. And while that could be seen as convenient to some people, I find it a little odd.
You'd want
there are a couple functions
to give you true or false.
Yeah, there are a couple functions in the standard library that in the spec that actually do work that way, like digit chart P, for example. Digit chart P tells you if a character is actually a digit. Right, but it also returns the digit that that character represents for the truth value, which is really convenient, but leads to code that looks very strange because there isn't actually any other function in the standard library. I don't think there might be one, but as far as I know, there isn't another function in the standard library that does the conversion. They just sort of merged those two functions together.
Interesting. Wait, does it return multiple values, or is it? Oh,
nope.
Okay.
It returns nil if you pass it a non-digit character and returns the digit if you pass it a digit character. So you can use it as the test to see if something is a digit character, or you can use it as the conversion function. But that just seems weird to me. And it leads to code that looks very strange.
It certainly does. That particular return value thing, though, is something I'm going to make note of because I forgot that and in that case doesn't do true or false. It returns the value, the truth value of the last expression.
And or are both just shorthands for using if. when it comes down to it. So and is it's literally just it's if the first thing and the rest of the things is the true case. And so then, that recursively expands to if the second thing and the rest of the things until you get to the base case, which is, it just returns the last value. And so, and doesn't do any sort of, bool conversion at all. It just, short-circuitingly tells you if everything is true.
It just expands to a nested set of ifs, essentially.
Yep,
behind
pretty much.
Okay. Gotcha. Okay. Well, that makes sense if you're implementing and. I mean, that's.
You can actually see that if you macro expand it.
No, keep forgetting the freaking.
Yeah.
Slime.
Have to be on the open paren. Gets me every now and then too.
There we go.
That the discussion of and or being shorthands is also straight out of lambda calculus, right?
True.
Yeah. Right. True. Get it? And I just tried it. You can do just out of curiosity. I tried if 2 and it returns 2. I guess I should try if 2 3 to be a little.
Yeah. Anyway, that's neat. But yeah, so as you could see, it's just
it's a series of ifs.
First thing, second thing, and if you have more items in there, it'll have nested ifs. It's reasonably straightforward. But yeah, anyway.
So we digress, but it's a very important thing to know at least how some of these things are implemented, because then you can get a notion on how even the compiler kind of like would generate. If you're at least using compiled x86 code, you can actually look at the compiled x86 instructions that are coming out of the Lisp compiler to see how it's going to get generated to confirm what's happening. I occasionally do that just because I like looking at the disassembler that comes out of the functions to understand that. But that's a discussion for a different day. We then go on to create a function called pathname has directory, because pathname has directory just takes in a directory, checks to see that if it is a pathname, and then returns a pathname object with the directory object created for, the pathname object with the directory component populated correctly. So then you can actually use this pathname has directory, which we'll show on later on in listing files. In some cases, like in probe file, you may want the reverse. You want to check if the pathname is as a file. And this is particularly important because, unfortunately, and I mentioned this later on, some Lisp implementations, in particular, I think the book mentions C-Lisp having this limitation at the time that it was written, and don't know if it's still the case. It treats files a bit different for existence, and its probe file function actually acts a little bit different. But we'll discuss that when we get to probe file. So moving on, this is what we'll create to our first pass of list directory. Oh wait, there's one more thing. In C-Lisp, and this is, I think one thing I noticed when I first read this, and I forgot about it when I took a while to actually, when I recalled to reading this chapter, is C-Lisp had some interesting quirks about itself that ended up requiring, some changes to be added. Like in particular, in this case, that you're seeing here with directory wildcard, its notion of wild doesn't work quite well, because directory won't return files with no extension unless the type component is set to nil, rather than the actual wild path name, which I'm a bit surprised, but okay. So you have to write a convenient function to actually go and handle that particular case. And so here you'll see that if we're not in C-Lisp, then we're just going to go ahead and use normal wild. But if we are, we're going to go ahead and set this guy to nil so that list directory will actually work correctly. And behind the scenes, that's what we're doing here. We are actually checking to see if it's a wild path name directory. If it is, we're not going to correctly list anything because you can't. We don't want you to specify as an end user the wildcard. We'll do it behind the scenes for you, and then we will return the listing of the directory based on it being passed to directory wildcard, which will handle the CLisp quirks. This exercise, this involved exercise, I think in a nutshell shows not only how to write the portable code, but also something else, which is like when you're first starting out writing at least Lisp programs, leveraging your particular Lisp features is not a bad thing, because later on you can always, wrap it around a readtime conditionalization statement to load it. So that way you can account for different Lisp implementations, quirks, and it'll allow you to write better Lisp libraries over time.
Although before you do that, do check to see if somebody else has already taken on the mantle of maintaining portability for that specific thing for you, because having multiple people trying to keep, portable versions of things just makes everybody's life worse.
Yes, so that's a very good point. Thank you, Elijah, for bringing that up. Yes, please look at, and there are plenty of resources. I might, just bring this up for discussion on all the different resources people have in actually looking for Lisp libraries, not specific to QuickDocs, which is what I tend to use all the time. There's also commonlisp.net, clicky.net, and all these. But we'll discuss this as time goes on, so that you know what libraries are available and where to look for them. So that way, your development experience is as pleasurable as possible as you start writing more common Lisp code. When we look at this list directory function here, this portable one that Peter wrote, you might be thinking that it will work for all cases. Well, that's also not entirely true. Depending upon certain Lisp implementations, they have certain additional features. The book goes into more detail on that. So one thing you can do is like, for example, let's talk about OpenMCL. So OpenMCL doesn't actually return appropriate subdirectories unless you pass an additional flag to the directory function in order for it to actually go in and return everything inside the Lisp implementation. Or we've talked about CLisp's issues with wildcards. To handle all these cases, though, you can write the following function. We can expand what was written earlier. Say, okay, if we're using SBCL, CBCL, or LispWorks, go ahead and use the normal built-in function. But if you're using OpenCL, use the built-in function directories true, so that way we have consistent behavior between OpenMCL as well as SBCL, CMU, and LispWorks. In the case of Allegro, we had to also pass in a flag calling directories are files is set to nil, so that you're actually going through and dealing with subdirectories as well. Here, you notice that we're using our local function directory wildcard, but also CLisp has an additional subdirectories wildcard already defined that you can leverage to actually list directories in that particular Lisp. Of course, as I mentioned earlier, and for those just joining in, if you're looking at this in Emacs, everything that's actually ignored is going to be in red. So none of this is actually going to be read into the Lisp runtime when we are actually compiling the initial system, at least on SBCL, CMU, or LispWorks. When you load it in Allegro, you'll end up, of course, seeing this being executed instead. Any questions about this? Because
what is that function actually doing? Listing files, listing directories, both?
This is just listing directories and subdirectories.
Okay.
So this was actually brought up, I think, not UIOP. What was the other one that I was thinking of? Someone actually went ahead and took Peter's implementation verbatim and actually put it into a third-party library. I think it might have been, is it Alexandria that has this? I think it might be.
That would probably be CLFAD. I'm pretty sure.
Oh, it's CLFAD.
What are you looking for?
CLFAD, yeah. CLFAD actually has this, is the portable library that implements Peter's implementation verbatim. So if you, this is already available for folks who want to just use this particular implementation. I don't recommend it. There are better libraries already available for you. We mentioned one last time called UIOP, which has some very fast libraries for I/O processing, amongst other things, and it's used by ASDIF and QuickList as well, just because to deal with file I/O inside any Lisp implementation. It's fairly portable. So my suggestion is if you really want to study this a little bit more and see what more things people have done with this base library, there's CLFAD. But in general, my suggestion, I think others have already mentioned this last time, is leverage UIOP for
yeah, UIOP actually completely overlaps CLFAD.
Yeah. Do not use.
It's just less well documented.
Yeah, and even though it overlaps it, a lot of the stuff is implemented so badly. Like, for example, look at the implementation of directory files in UIOP. It's filled with ignore errors, which you should probably never use in real life.
Well, it's funny you mentioned that, because later on, I think we use ignore errors.
But it's surprising that it works so well.
Yeah, ignore errors is one of those things that I wish was never really put in the spec, to be honest. Like what you should have is something that, and I'm pretty sure Serapium has this. Another one of the utility libraries is ignore error, I think, or something along the lines of that, which is it ignores a particular error. It returns nil in the case of that particular error or any of its subclasses being, spit up. And if you absolutely need to have a generalized version, ignore errors on, I think, standard error is the superclass of all errors. If you really want to do that,
ignore errors should not be used at all, especially by libraries. I mean, at the very least, it should be used at the outer level in user code.
Yeah.
I mean, people should be able to catch these errors and handle them how they want.
Yeah.
Right. So you'd say a better approach is to leverage handler bind and set up appropriate.
Yeah, handler bind or handler case, depending on your purpose. Yep.
Yeah. Okay. Well, ignore errors, I'm pretty sure, just sets up a generic handler bind or a handler case and just returns nil, which, no.
No.
No, which is why, like, I'm more okay with something where you have to explicitly specify exactly what classes of errors you're ignoring, because
you're documenting at the very least explicitly in your design. By the way, I don't care about these things.
Yeah, these particular cases, it just should return nil for. I would write that out as a handler case, but it would take too long. But but at least there's that. But ignore errors just in general is terrible, and yeah.
And is ignore error, is it Seraphim like this?
Serapium.
Library?
Serapium. SERAPEUM. Yep, that's the one.
PEUM.
Yeah, that's another utilities library.
Utilities library, which
5 million.
Yep.
Well, obviously we can build yet another one, but then we'll have 5 million in one libraries that are utilities libraries. So Which has the ignore. This is the one that has ignore error, not
Actually, it's called ignoring. You know, but it's that it's ignoring, and then you give it a particular error class, and it ignores specifically those ones, which is at the very least better than ignore errors.
Right.
It's
If
better,
you have
finer
to.
control over
but
which
still,
error.
It's
it
still
rubs me the
bad.
wrong way. I don't like that.
It's still bad, but if all you are going to do is handler case that error and return nil anyway, it's better.
It's better than it's better than doing that.
Yeah. You know,
it's still bad, but it's better than doing what
at the very least, it means that if an error occurs that you weren't expecting, you aren't going to silence it, which is the
Right.
problem with ignore errors just like in general. If an error occurs that, you didn't really mean to handle in that way, you've just screwed over someone debugging.
Right.
which is why ignore errors should never show up in libraries.
Oh, never.
Yeah.
See, life lessons are coming in while we are in the study room. Another lesson learned. I'm just going to go ahead and write this for folks who are watching this so they could pause it and do not use.
The only time I've ever used it was in a one-line shell script that wanted to bypass some error in QuickList or something or other, but never in a library. Never.
Never. In a library. There you go. So profile, as we mentioned, I think last time, I'm just going to mention again here, is normally used when you're just checking the existing profiles, or I think even you can't use it for directories. I don't think so. It's just for files. They have in at least C Lisp, and there are other equivalents in other Lisps as well. There's probe directories that you can use to as well to do something as similar. In our first example, we have a function called file exists p that we're essentially leveraging, and what it does is it checks whether or not it's a path name, or if it's has a directory, and then checks to see if that probe file exists. So probe file would get passed in a path name object with the appropriate components populated based on the directory components, and it'll check to see if the file name exists or not. In the case of C Lisp, though, C Lisp has two different they have two functions. Normal probe file actually errors out if you actually try to pass in a path into it that is not an actual file. If it's a directory, it will crap out on you, and it'll throw you into the debugger. If you wanted to do that in pure C Lisp, there is an extensions namespace with a function, as you see here, called probe directory, that allows you to do directory existence. And what we have done here, and what again Peter has done, we can see that we can actually go ahead and write a general function like this that would allow us to go through and check to see whether or not we are a directory or a file, and we wouldn't have to care about it anymore. The overarching theme of this entire case study really is yes, at least when it comes to file I/O, there are very convenient implementation-specific libraries that one can leverage. But if you wanted to write portable Common Lisp, there are third-party libraries available. But as it stands, you can also, if you don't know what third-party library exists for it, you can also write a portable library for it if you need to. But please, as we mentioned earlier, check the existence for a third-party library before you start writing out the portability library for a specific piece of the Lisp systems that you think you need to have portable API for. Finally, I'm just gonna just check my notes in my notebook here. Give me a second.
And by the way, UIOp has a custom probe file version that wraps everything and ignore errors.
Excellent. Oh, jeez.
I suppose if anything goes wrong, you're safe to assume the file isn't there. Yeah, no, that doesn't make any sense. Nope.
Jeez. So, of course, after some time, you may want to write something like walking through a directory tree, because as you're going through your file system, especially if you're going through directories of files, you may want to have a convenience function that you can pass in a simple like transformation function, and it will go behind the scenes and then walk through the directory tree and apply the function to each file in the directory tree. So this is a primitive. Obviously, there's more full-featured ones in this already available to you in third-party libraries that you could write that will allow you to recursively go through the directory tree and walk through it and apply a function to particular file names and path names that are available there. This actually culminates and it combines all of the stuff that we talked about earlier, all the little functions that you built up, and you created this high order function that takes in a function, has an argument, and that applies it through the use of this function called funcall, which I don't believe we've actually visited, but we may have touched base on it in earlier chapters, especially when we started talking about applying a function to like a collection or a particular object. But that's it for this chapter. Actually, it was a pretty small chapter. I wanted it to be pretty small for this week to complete, especially our discussion on file names and file IOs, and at least introduce you to, as I was mentioning earlier, some of the resources that are available to your literally at your fingertips, because the internet gives us this has grown a lot of these Lisp resources that have a lot of nuggets of information. So I'm just going to switch screens here if you give me a minute, and I'm just going to share my browser here so that we could take a look at a couple of these and discuss some ways of leveraging. Come on. There we go. Can you guys see this?
Yep.
Yep.
Excellent. Okay. So the first library that site that I want to show people is QuickDocs. This is what I tend to use to actually look up APIs. It actually does a fairly nice job in showing off the API reference cleanly. So as you can see here, what it normally does is it extracts, the README that's inside the GitHub repository and shows you how to what its initial project intentions are. But more importantly, if you go to the API reference, it will give you literally all the symbols that are available for you to use, and whether or not they're classes or generic functions. So this is a nice resource for folks to actually look for third-party libraries to see if they are actually in QuickList. You can use apropos to actually go in and look up libraries and see what versions there are. I normally recommend, I don't know what others recommend here, but I normally recommend to use the library that's already available in QuickList instead of having you download it and put it in local projects, because it's easier from a development standpoint just to get everything from QuickList. What are your recommendations on that, Michael and Elijah?
I mean, yeah, like I would definitely prefer QuickList libraries to non-QuickList libraries, especially if it's something you're planning to share with other people. If it's just something you're writing for yourself, I mean, there are still some things that aren't up in QuickList, and so, you know, in that case, it's not as big of a deal to clone to local projects. But as a rule, yeah, and QuickDocs is a great place to find libraries that are in QuickList, but it gives you at least a slightly, you know, more useful search and, you know, at least a listing of everything you have available. Although API docs they're never quite enough.
My biggest complaint with QuickDocs is it only scrapes documentation strings embedded right into the functions. You cannot set F documentation. They won't catch that.
Yeah, that's frustrating. I can kind of see why it's done that way, but that's kind of frustrating. It would be nice if it actually loaded the system and asked the running Lisp implementation for the documentation like you're supposed to, but I guess they just don't have the time to do that. You know, load every single system in QuickLisp into an image and then test it.
Yeah, that's what Staple does. Shinmera's little tool there.
Yeah. That's the right thing to do.
What was that tool that you mentioned?
Staple. You can't browse documentation online, but you can generate it for any system.
Oh no!
Should you download it and do it yourself?
I heard your tool called Staple or something like that.
Yep. It's let me see here.
So there is a tool, folks, that you can allow you to inspect the documentation. If I can just grab it for you guys, it would. So is it Staple Common Lisp like this in my search window? If your guys are able to see it.
I actually have an example of what it could look like on my website.
Nice. Okay, so I'll just go to your website. I think I have it bookmarked. Yes, I do. I have your FLAC website there. Okay. You guys can see, yes, you can. All right.
Yeah, if you go to projects and any one of those, first one's okay, or that one, yeah. That's just the README. That's scraping, it's pulling the README out of, you know, the GitHub files. And then if you go to the bottom, it's the package index is the actual documentation.
Nice. Okay. Cool.
Function, generic function. Then it has the doc strings. Tells you what it takes. It's the function signature and everything.
And does this get generated? And you're saying that this gets generated with your default style sheet through Staple?
Yep.
Okay. So for folks who are just joining in, I'm guessing Staple would be in.
Yes, it is.
Here we go. This is the documentation tool that Michael was bringing up. Helps you scrape your your Lisp systems, so that you can grab its documentation, and you can actually generate these very nice websites with very quick examples, as well as it'll also get the doc strings too as well. So that's this alone should tell you that documentation is not is a thing that we have that needs to, well, in some way, shape, or form. There are good libraries have lots of documentation, and bad libraries have lots of documentation.
Did we talk at all about meta period? How to jump to source?
No, we have not talked about meta period. The reader macro,
okay,
right?
Well, when we do, that's probably the best source of documentation you have.
Yeah, we should have at least some day in which we go through a lot of the slime key bindings and such, because there's a lot there. Yeah, meta period, or you know, it's equivalent to any of the
Control-C, I think when we did the initial
Control-C, Control-D is describe symbol. Meta period is jump to definition.
Oh, Gotcha. All
Much
right, I
more
see what you're saying.
convenient when there isn't actually docs.
Right.
Although telling someone read the code is never the right answer, but you know, it
Right. It's often
it
an
gets the
answer.
job
that's
done. Yeah, it's often the answer you're stuck with.
given. Right.
So
Man.
and
So
in general, CL code is at least reasonably readable. And when you have things like jump to definition and pop definition stack, you can usually hop around the code and figure out what's going on reasonably easily.
right,
So
absolutely. So two other sites that I want to mention. I don't know how much more information, but I will say that they do have certain pieces of information. Certain pieces of information that aren't available in QuickDocs is Clicky and CommonLisp.net. They're basically the same sort of things. Like they have documentation from a lot of third-party libraries that are available. Clicky itself also gives suggestions for like Lisp books. When I first started out, I remember going to CommonLisp.net and Clicky and going through and looking through these pages. It gives you nice suggestions too as well. Has exercises, tutorials, and other things. And of course, it has links to all the various IRC channels that on Freenode that you can access. That will certainly make your lives a little bit pleasurable. Just a word of caution for those of you who haven't touched IRC, especially those of you going into the Lisp channels. I suggest you start with CL noobs and work your way up into the other Lisp channels because
Yeah, it can be a little harsh towards newbies.
And they will. Some people are very, very, very helpful, and others will make you feel like you're like the scum of the earth, just because you asked a question, even if it was a legitimate one. So do not fret. Do not get depressed. There are other channels on Freenode that will help you certainly adjust to picking up things in Common Lisp, and I certainly hang out on there. I don't know if others on the channel do. I periodically go into there, so if you guys see me, my Slack handle and Discord handle are the same on IRC too as well. So feel free to ask me a question. I'll answer it the best I can. Finally, of course, this is probably the oldest one, but it looks like they had a revamp here because I have CommonLisp.net has been around for years, and I haven't visited recently, but it looks like they've actually revived the site and gave it a fresh coat of paint because it has some really nice organization here. It has some good tutorials that you can certainly leverage. Of course, different mailing lists and projects that they sort of either are behind or have been actively following. This is certainly a good place, again, on top of what I showed you earlier with QuickDocs, for you to go in and click on a particular project, and it will, if it exists, there will be documentation associated with it. I think one example of this would be Cells, because I think Cells is still available here. Yeah. So these are various, documentation sites, various project sites that you can get third-party libraries from. Obviously, as Elijah and Michael mentioned, the easiest thing to do is either look in the source code for things that are undocumented, or Slime has some very nice key bindings that we will bring up in the next discussion when we start it. Just that you can use at your disposal while you're actually writing Lisp code, so you can not have to switch between windows, especially. And Slime has, I think I mentioned in earlier talks and earlier study groups, it has more than that. It gives you some very tight integration with the hyperspec that you can certainly leverage as you are exploring the language and doing advanced functionality. So that's all I have for today for material. Any questions? Michael Gargano, I see that you've been muted for a while, so I'm going to ask you first.
No, not today.
Ah, sweet. All right. Judd, any comments from...
No, I'm
You're
fine.
good.
Yeah.
Okay, cool. Well, then again, next time on the Common Lisp Study group, we're going to be starting our journey in object-oriented programming in Common Lisp. This is, again, a pretty involved topic because Common Lisp's approach is definitely different than other languages that you might have used. And I don't know exactly the best way to explain it other than to, hit the ground running and show you. But I'm going to let you guys first read through the chapters too. That is, if you guys are curious, it is going to be chapter 16 and 17. And if we can get through all that quickly, chapter 18 will also be involved in there too as well. So that way we can get started on a few format recipes and prepare ourselves with for the other big discussion in Common Lisp, which is exception handling, which is sort of started earlier today. So if there aren't any other questions, I'm just going to sign off. Thank you guys for joining me. Michael and Elijah, thank you for taking the time to come in. Thank you, Judd and Michael Gargano, to actually join in on the live conversation. Any of you who are still listening in, just a few more reminders. One is primarily we have the Lisp Game Jam coming up in April 20th. We have 1 month exactly now for the most part. This Game Jam is an educational experience. You can write a game in any dialect of Lisp, not only Common Lisp Scheme and Emacs Lisp, but Clojure as well and ClojureScript. Michael, do you have any logistics that people have to be aware of? Is there like a deadline for teams or whatever?
There's no deadline to sign up. I mean, the Game Jam starts exactly when that countdown ends, and it lasts exactly 10 days. I mean, there is there's an IRC channel where a lot of the participants hang out. It's
Is
it's
it
probably
just
on
Lisp
that
Game Jam?
Yeah, no, it's Lisp
that one.
Games. It's on the bottom of that page, actually.
All right, hold on, going back.
If you need help or you're looking for a partner or whatever, you can just go to one of those last 2 links at the very bottom there. Either Game Dev on the Lisp Discord server or Lisp Games on the Freenode IRC channel. A lot of people that usually participate are on the IRC channel, and there's actually a few that are going to be participating on the other link there. So if you have any questions, anything, just ask. There's tons of people that are be more than willing to help you.
Michael gave us a very nice thing, some very nice resources also for you to get started on your exploration. You can choose the Lisp that you're leveraging here in the Lisp Game Wiki, and it'll give you some suggestions not only on basic things like window management and graphics, but they actually have full-blown game engines available here. I don't know exactly whether or not how mature some of these are, just because last time I touched it, I think I touched Blackthorn and it wasn't. It looks like it's stalled now. Yeah. I haven't touched this, but there are plenty of things for you guys to get started and try things on and experiment with. So Until next time, this is Ron Vadum with Atlanta Functional Programming signing off. Thanks, you guys, for all of you coming. See ya.
Bye then.